Rules for formation of images by spherical mirrors. These rules help us to draw ray diagrams. Here let me see the first rule. This is a concave mirror. An incident ray parallel to the principal axis after reflection passes through the principal focus. We know this from the definition of the principal focus or focus. The incident ray which is parallel to the principal axis after reflection actually passes through the principal focus in concave mirror. And when you come to the convex mirror, the ray parallel to the principal axis after reflection appears to coming from the focus or directed in the direction of the focus. An incident ray of light parallel to the principal axis after reflection appears to be coming from the principal focus of convex mirror. That is first rule. Come to the second rule. An incident ray which is passing from the focus. Here we determine the direction of the reflected rays using the laws of reflection. Here our incident ray is passing through the focus and AC is normal. After reflection, reflected ray passes parallel to the principal axis. This is second rule. Come to the convex mirror. An incident ray which is directed towards the focus. This is one incident ray which is directed towards the focus, and this is normal at this point, and away from the normal this is reflected ray which is parallel to the principal axis. An incident ray of light which is directed towards the principal focus of convex mirror after reflection becomes parallel to the principal axis. This is second rule. Rule 3 gives us the direction of reflected ray when incident ray is passing through the center of curvature point C. So let me see. This is one incident ray which is passing from the C and strikes mirror at A. This AC is the line normal at point A. So our incident ray is passing through the normal. So when it is passing through the normal at point of incidence, it makes 0 angle. So angle of incidence is 0. When angle of incidence is 0, angle of reflection also 0. So that reflected ray comes in the same path but in opposite direction. So reflected ray retraces its path when incident ray passes through the center. Suppose this is the incident ray direction. This reflected ray retraces its path. Here angle I is equals to angle R is equals to 0. Our third rule is a ray of light which passes through the center of curvature of a concave mirror. After reflection, it retraces its path. Come to the convex mirror. A ray of light which directed towards the center of curvature. Here, center of curvature of a convex mirror is inside the mirror, so that The incident ray cannot pass through the center of curvature. It is directed towards the center of curvature, that is normal. So it retraces its path. This is the direction of the reflected ray. And when it is directed towards the center of curvature, it retraces the path. From this rule, we also can know that the incident ray which is passing from the principal axis, after striking the mirror, it retraces its path. And now come to the rule 4. A ray of light incident at pole. A ray of light which incidents at pole. Suppose this is a ray of light which incidents at pole. So it is making certain angle with the principal axis. So with the same angle, it reflects away from the principal axis. This is the direction of the reflected ray. Or suppose at any other point, this is the point A, then reflected ray direction is, this is the direction of the reflected ray. And here you take the convex mirror. When one light ray incident at pole, then making equal angle of incidence, a reflected ray goes away from the principal axis. Suppose one ray incident at point A, suppose that, then reflected ray direction is according to the laws of reflection. What is our fourth rule? A ray of light incident at pole or at any other point of the mirror goes in a direction according to the laws of reflection, that is making equal angle of incidence. Angle I is equals to angle R. Ray diagrams for image formation by convex mirror. Ray diagrams are helpful in finding details of image formed by mirror when object is at different positions. Here we draw a ray diagram to know the nature of image formed by convex mirror when object is at infinity. To draw the ray diagram, here I am using one compass and just measure the length. This is 4.5 centimeters. By taking the 4.5 centimeters, draw one arc. Now whose radius is of 4.5 centimeters. So at this point, this is the center of curvature and this is pole. Now our radius of curvature is 4.5 centimeters. So at the midpoint 2.25, here this is point is the focus, because focus is the midpoint of the pole and center of curvature. And now join one line such as this line connects pole, focus and center of curvature. Now this line is the principal axis, and now shade inner part of the mirror, inner side of the mirror. Now this M1 is convex mirror because inner surface is silvered or polished and outer surface behaves as the reflecting surface. Now let me take one object which is at infinity. So draw two incident rays which are coming from one object which is at infinity, and these two incident rays are parallel to the principal axis, and They strike mirror at two different points A and B. To know the direction of the reflected rays, first you draw normals at point A and B. This is normal at point A and this is normal at point B, and now reflected ray direction is away from the normal by making equal angle of incidence. So now this is the direction of the reflected ray of first incident ray, and second incident ray goes in this direction. Now these two reflected rays form one diverging beam. They never meet. So to obtain one image, now we had to extend the reflected rays. Just extend reflected rays backward onto the principal axis. So these two extended rays meet at one point on principal axis, that is on F. So image will form on principal axis at F, but this image is not because of the rays actually meet at that point. This image has formed because of the extended rays of the reflected rays. Such image is called as virtual image. So when object is at infinity, convex mirror can form one image which is at focus, that is behind the mirror, and the nature of images, that is virtual image and erect image. Usually virtual images are the erect images, and when you see its size, it is a point size image. Now come to the one object which is between infinity and pole. Now draw one object. Just we take one object which is of 1 centimeter length, and this AB is one object which is in front of convex mirror. This is one convex mirror whose inner surface is silvered, and our object AB, whose height is 1 centimeter, is in front of the mirror between pole and infinity. When object is at measurable distance, to draw the ray diagrams, we have to draw two lines, two incident rays, which are originate or start from one point of the object. So now I am taking two rays which start at point A, but they must be in different direction. We have to draw the two lines from same point but in different directions. So first ray is parallel to the principal axis, and second ray is directed towards the center of curvature, and the ray which is parallel to the principal axis always reflects in direction of the focus in case of the convex mirror, so that this is the reflected ray direction. So when you extend this reflected ray, then it meets focus, and the ray which is directed towards the center of curvature always retraces its path. So this is the in same path reflected ray goes. Now this is the point where two extended rays of the reflected rays met. So at this point we can obtain one image. This is the image, and when you observe this point, This point is the intersection of the reflected rays which are coming from point A. So that this is the top of the image. And when you see this part, here, this is the ray which is coming from the bottom of the object. So in the image, this is the bottom. So this A dash B dash is the image of the A B object. But this image has formed by intersection of the reflected rays. But these reflected rays not actually intersect at this point. These These are the rays which are extended rays of the reflected rays. So by the extended rays of the reflected rays, the image has formed, so that this is one virtual image. And its upside is upward the principal axis, so that this is one erect image. When you observe the size of the image, object size is of 1 centimeter, but this is less than 1 centimeter, almost half centimeter. So its size is of small size. So now let me see the nature of the image. When object is between infinity and pole in front of one convex mirror, then position of image is between P and F, that is behind the mirror. And the nature of image is, it is one virtual image and erect image, and it is of small size. Now some questions on this concept. Can a convex mirror burn a paper? If not, why? Our answer is, the rays that incident on convex mirror after reflection diverge from the mirror. So convex mirror cannot burn a paper. Second question, what is the size of image formed by convex mirror? Size of image formed by the convex mirror. Our answer is, the size of image formed by convex mirror is always diminished. That is small size image. Our next question is, complete the following ray diagram. Here a ray diagram is given. First, what kind of mirror it is. The incident ray direction is given. It is on outer surface. So outer surface is behaving as the reflecting surface. So this is one convex mirror. So first shade the inner surface, and now see the what is the direction of the incident ray. Now our incident ray is directed towards the mirror, and this is parallel to the principal axis. This incident ray is parallel to the principal axis. When incident ray is parallel to the principal axis, then what is the direction of the reflected ray? It directs in direction of the focus. So this is the direction. And one more we can do, that is we can draw the normal also, which joins the point of incidence and center of curvature. Thus we can complete the ray diagram. And next question is, what is a virtual image? Our answer is, if the rays do not actually meet but appear to meet at one point, the rays do not meet actually but appear to meet at a point, the image formed is a virtual image of the object. A virtual image cannot be formed on the screen. That is, we cannot catch the virtual image on the screen. Our next question is, through which point will the ray travel after reflecting off the mirror? Here one mirror is given, and we know this is one convex mirror, right? And this is the incident ray because arrow is towards the mirror, so this is one incident ray. Now here 2 points are given, one is x on principal axis and one is y away from the principal axis. Now our question is through what point the reflected ray goes. Here this point is on principal axis and this is away from the principal axis. But if the mirror is concave, then obviously the ray goes from the x. Concave mirror always directs the reflected ray towards the principal axis. But here our mirror is the convex mirror. This is shaded inside and outer side is behaving as a reflecting surface. When incident ray is parallel to the principal axis of convex mirror, then reflected ray directs away from the focus, in the direction of the focus, away from the normal. So this is the direction of the reflected ray. So our answer is reflected ray will travel through F. Thanks for watching.